So finally, we're up to the last question here. So this is an AP free response question from 2012. So it tells us that the function f is defined by f of x equals square root 25 minus x squared. It asks for f prime. So we need to differentiate this function. So for part A, we're going to find f prime. So we're going to differentiate. This happens to be a semicircle function. So f prime x is equal to 1 over 2 square root. Okay, this is a embedded function, so we do need to apply the chain rule here, times negative 2x. We'll simplify that into x over square root 25 minus x squared. Okay, so this is defined from negative 5 to 5. So part B then asks for the tangent line. So our tangent line, we need a point, and we also need the slope. So we'll first start off with the slope because we can find the slope from our derivative. So slope at negative 3, when we plug in negative 3, we end up with negative 3 over 25 minus negative 3 squared square root. Okay, working this out, 25 minus 9, we end up with, that would be 16. Square root of 16 is going to be 4. So there's our slope, negative 3 over 4. We also need an x and y coordinate. So for an x is equal to negative 3, the y coordinate, which we're going to plug back into the original equation, the y coordinate works out to be 25 minus negative 3 squared, which is again 16. Square root of 16 gives us 4. Okay, so this is our x and y coordinate. To find the equation of the tangent line then, we'll use our point slope form, y equals slope times x minus x naught plus y naught. And plugging that in, we end up with negative 3 over 4. That's our slope. Our x coordinate is going to be negative 3, so we end up with x plus 3, and our y coordinate is plus 4. Okay, so now we've got our equation of the tangent line. So that's the answer to question B. For part C of this question, it says, let g be the function defined by f of x from negative 5 to negative 3, and from negative 3 on, it's going to be x plus 7. So it's going to be a semicircle function, and then it's going to be a linear function. So if we're just kind of thinking about what this might look like, it's going to be a curve like this, and then we should have a slope that looks like this. Okay, and we don't know exactly this. Well, I should maybe redraw this slightly. We know it's curving up, and then we're not sure what's happening right at that point. Okay, so this is what we're going to check for. So we're going to check first of all for continuity. Okay, so it says, is G continuous? So we're going to check for continuity. So checking for continuity, what we're going to do then is we're going to check to see where the first part of the function, so in the domain negative 5 to negative 3, for that domain, we're going to use f of x. And the point that we're going to test is where x is equal to negative 3. So we want to test f of negative 3. And we already figured out f of negative 3 is equal to 4. Okay, so that y coordinate on the curve is equal to 4. And what we're checking for then is we also need to check then is the y coordinate on the line, so on the domain negative 3 to 5. Okay, we're going to check to see if that part of the function is equal to 4 as well. So we plug in 3 plus 7, and we end up with 4. So those 2 points match. Okay, so what we know then is that as we transition from the curve to the straight line, the y coordinates at negative 3 both match. So this then is continuous. So we will write that down more formally. We know that the limit as x goes to negative 3 from the negative side of f of x is equal to the limit as x goes to negative 3 from the positive side. Okay, so therefore is continuous. Okay. Now there's a secondary question here in that, is this a differentiable point? Okay, this is a slightly tougher problem in that we do need to then check to see if the slope at that point is the same, okay, as we approach, or is the derivative continuous? Okay, so we're looking for the continuity of the derivative. So I'll call this part C, part C2. Okay, and this is it differentiable at that point? Okay, so we need to test to see if the limit as x goes to -3 from the positive side of f prime, oops, sorry, it's g prime, isn't it? We have to call that g prime of x is equal to the limit as x goes to -3 from the negative side of g prime of x. Okay, so g prime of x from the negative side is going to be the semicircle portion. Okay, and we know that that is going to be the limit as x goes to -3 from the negative side of f prime of x, okay, which I'm going to replace with our expression. Our expression was x over square root 25 minus x squared. And we also then need to test for the slope from the positive side, which represents the linear function. Well, the linear function is easier to calculate because if we take a look at the linear function, the slope is constant and it's equal to 1. So we're just going to say that limit is equal to 1, okay, because it's always equal to 1. So as we test this then, is as we let x goes to -3, we already found the slope at -3. The slope of -3 is equal to -3/4. So when we take a look at this, are these in fact equivalent? Slope of 1 from this side. On this side at -3, the slope was -3/4. Okay, so clearly this is not true. Okay. It looks like, there we go, yeah. So it looks like it's not true. So we end up with this expression. These are not equivalent. Therefore, the slope, it is not differentiable. So the slope, there's a kink in there, so it's not differentiable. Okay.